Hi, MC Bling Daddy here with the 10th video in the CBC Coding Engine series. You may want to review previous presentations for details on using the coding engine and how, with the pseudocode found in the comments section of this video, it can generate command block code used to create the objects we'll see here. We're still using some of the same world code region we created before, but we've removed the previous tower and the main code sequence, keeping the subroutines. We've shown all the essentials on how to use the engine, so coding blocks for the pseudocode have already been created and debugged. The defines and presets have been changed to define and preset a few new vars, as well as the standard for loop variables. The command blocks for this can be found off to the right of the main code path, just near the code region origin. So this time we'll just start with a look at a run of the pseudocode. The vantage point is down the main code path about where the third for loop is. It combines multiple functionalities developed into a fully functional Minecraft feature, a multi-unit multiplex, suitable for Minecraft dwellers to inhabit. Additions or modifications can be made as desired. And the bonus is that since all the parameters on size are coder supplied, it can be created in almost any size needed. The one thing that is needed, though, for a future possible video is that W be greater than H. Let's take a look at the code execution and discuss a few critical Minecraft commands used in the code. The view we'll switch to is located at about the third for loop down the main code path, and the video is sped up quite a bit. Case 12. Here at the beginning is one of the most interesting commands I see needed. You'll see the teleport of a marker to the circled block. The command is in effect a multi-parameter AND test. It's a series of if-test executions, each of which must succeed in order for the next to be run. So all of the tests must pass for the final command to execute. The combined test is for the exact location in each unit at which the construction of the next unit will start. And then a marker, WA2, World Anchor 2, is teleported there to sit and wait for the next unit's construction to start. And the combined execute commands in a single Minecraft command could be considered a template for complex AND statements to augment the redstone AND logic currently used in if statements. Back to execution, analyzing from bottom up, we see that we start with rows of blocks. They form an octagonal loop. Succeeding loops are concentric within the first, and the octagonal loops form the first construction phase of the floor. Loops after that are rectangular and form the second phase. After returning to the floor's starting point, a wall loop starts. Partway through the first wall loop, though, a marker, an armor stand, is set to mark the location of the start of the next unit of the multiplex, as noted before. Each story consists of a floor and one other thing. All the bottom stories have walls, but the top story has a roof instead. And a roof is essentially a floor with each loop elevated one level higher than the previous. You can understand that if you were to just drop all the roof loops down to the level of the lowest one, all of the same blocks are placed that would be in a floor. One tricky part here is the loop over construction phases that determine how the loops work, the C for loop. As set up, phases 1 and 2 are the same as 3 and 4, the first and second phases of floor construction. We have them twice because floors are included with both walls and roofs. There are a total of 5 phases, but some come paired, floor and wall versus floor and roof. It's a hack, I know, but if we set up wall as phase 6 and roof as phases 5 and 7, then we can do phases 2, 4, and 6 as floor, 2 phases, and wall, 1 phase. Or we can do phases 1, 3, 5, 7 as floor, 2 phases, and roof, 2 phases. So if we set up for loop C always with an increment of 2 as either initial value of 2, 2, 4, and 6, or initial value of 1, 1, 3, 5, 7, we can get either series exclusively. I have no justification for this other than it works and eliminates the need for an additional 4. So, several stories make up a unit, and a few units make up the multiplex. And let's take a look from the top down, the outermost 4 to the innermost. U, units, 3 in this case. S, stories. We've set up for 4, the topmost being the roof. C, construction phases, 2 for each floor and roof, 1 for wall. L, loops, typically octagon or square. R, rows, sides of a loop. B, blocks in a row. Okay, we've looked at the overall structure of the pseudocode. Let's take a look at a few specific commands that are required to augment the code. Case 1, teleport. Teleport is frequently used to move the WC to a nearby location or to another entity in the game. Minecraft doesn't have a way to specify movement with variables, so motion is typically 1 in some direction. To move to another entity's location, the @ pseudocode mimics the Minecraft command. We've looked at transfer, setpoint, and call functionalities as part of the engine already. So let's look at case 3, at how the non-fixed 4 parameters are evaluated. Things like C ini, L fin, and L inc. These are indeed variable and need to be set before entering the for loop. The command blocks that would normally set them have had commands substituted, tests to see if the parameter has actually been set or not, and reported if not. Case 7, another shortcut occurs in the setup for the next loop. The direction WC moves differs in different construction phases, as determined in the L loop by the C value in the switches. Typically, a block will be set under where the WC will move to, so it won't fall. Then the WC is moved to sit on the block. These could be handled by subroutines, but since there's only a couple of commands, it works effectively to put them in the command blocks that come at the end of switch cases. Case 8. Another case where the command needed for code is a bit complex, is variable assignments. It's necessary to use the entity that an objective belongs to fully identify the specific value desired. In this case, the number of blocks we lay down in a row depends on whether the row is diagonal or axial, lies in the direction of the X or Z axis. This corresponds to whether the row variable has an even or odd value. Hence, B sub E and B sub O. Well, that's about it for this demo. The objective was to show that the coding engine was capable of converting high-level code to command blocks required to execute it in Minecraft. The object constructed is fairly complex, but if time allows, we'll see about adding some finishing touches to the structure in another video, so it's even more appealing to potential residents. Note that there are some utility functions in the engine additions you'll find as usual in the description box for this video. And there are also some commands to change the switch functionality, so there are 6 commands now possible at the end of each case. As many as 6 in a single case were used in this demo. Well, thanks for watching, and I'd love to hear if anyone finds the engine useful and constructs something with it.